Testing. 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 All right, welcome to another Hoopo's stream here. Today we're going to be looking at YOLOv8, 8th version of the You Only Look Once, which is a type of computer vision model that was popular back in the day because there used to be basically a lot of two-stage pipelines in object detection and segmentation and these kind of tasks. YOLO was a one-stage pipeline, so it was a little bit faster, it was a little bit smaller, and it got popular. So over the years, they now have up to 8 of them. So YOLOv8 is the most recent one. I made the joke that this is basically the Fast and Furious franchise of computer vision models because they're also on 8. So this is the main GitHub repo here. Seems to be under the name Ultralytics. Ultralytics be a simpler, smarter, further. This is kind of startup or something. Ultralytics Hub, machine learning deployment platform. About. Okay, so this is basically just a startup that based around this YOLOv5, YOLOv8. Okay. Actually go to Crunchbase. Crunchbase is a kind of a database that allows you to search for companies. So there. Okay, so Ultralytics was founded in 2022. 11 to 50 people in Los Angeles, California. Our company. Where are their investment rounds? The CEO and the CTO is John Kablonsky, Len Jocker. They haven't posted any finance rounds, but I assume they're just working on seed round or something like that. Okay. Have the original YOLOv5. They have a YOLOv3. A lot of Python, Jupyter Notebook repos. Let's go ahead and just read through this README here. Cutting edge, state-of-the-art model that builds upon the success of previous YOLO versions and uses new features and improvements to further performance. YOLO8 is designed to be fast, accurate, and easy to use. Object detection, image segmentation, and image classification. Okay. So, installation, YOLOv8 docs for documentation. Why don't we install it and then we'll doc swap. The pym YOLOv8 pym activate so now that we're inside our little Python virtual environment called YOLOv8, let's tick. All right, so downloaded matplotlib, Seaborn, which is visualization data science dependency, HydroCore, PyYAML board, PyTorch, Pillow, which is an image library, SciPy, Pandas, OpenCV, NumPy, kind of generic. Deep learning tool. Okay, so go to the actual documentation page. Let's see. Ultralytics YOLOv8 is the latest version of the YOLO once object detection. Not all of them were developed by Ultralytics, so this is a little bit disingenuous. The original YOLO was developed Darknet. This is the original one. So I think YOLO v1, v2, and v3 were actually written entirely in this deep learning framework called Darknet, which was written by this guy called Joseph Redmond, I believe. He has a TED Talk as well. Kind of an interesting dude, strange man, but maybe some of the people that helped him eventually went and spun off into Ultralytics. YOLOv8 model is designed to be fast, accurate, and easy, making it an excellent choice for a wide range of object detection and image segmentation tasks. Trained on large data sets and is capable of running on a variety of platforms from CPUs to GPUs. Okay, so here they have a iOS and Android app. They have a model zoo where we can see the different models that they have. Okay, a brief history of YOLO. YOLO was developed by Joseph Redmond. Okay, the first version was seen and gained popularity due to high speed and accuracy. Really, the speed was the main part. Significantly faster. YOLOv8 in 2016 and improved upon the original model by incorporating batch normalization, boxes. YOLOv3 was released in 2018. Added a more efficient backbone network. I wonder if they use transformers for this backbone. A feature pyramid and then a focal loss. YOLOv4 was released, which introduced a number of innovations such as mosaic to augmentation. Crop rotation, flip hue, saturation, exposure, aspect. These are kind of standard forms of augmentation, but then there are more advanced ones: mix up, cut mix, mosaic, and blur. Okay, this is the actual YOLOv4 paper. And actually, we can go here. And you could see mix up, cut, mosaic, blurring. So this is the mosaic Got mix and blurring. You know, these performance numbers aren't necessarily huge here. With the data augmentation, or without 77%, 94 for top 1 and top 5. And with the augmentation, 1 or 2% more. So that was YOLOv8. They also had a new anchor-free detection head. So this is kind of the head of a detection model, right? Boxes, model. Yeah. So when you see object detection in the form of kind of bounding box detection like this, right? So most people will only ever look at the final result of this, right? Which is basically this picture here, which is just a sailboat, and you get the boxes or the sailboat. But there's actually what's called anchor boxes, which are basically starting points. So these boxes aren't just output from nothing. Actually, what you have in detection pipeline is you have a first model, which just basically takes your image, turns it into a map, right? And then you have a second model, which takes these kind of anchor boxes or starting boxes, and then goes from there. So one of the problems with this is that these anchor boxes are human defined, right? And they're specific to the application, and it's just one extra little knob that you need to tune based on what your model's going to be used for. So these have kind of, over time, different methods for not having these kind of hard-coded anchor boxes have come out. Like that's basically here. One of the main parts of YOLOv8 2020 was this new anchor-free detection head. Right. In 2021, Ultralytics released YOLOv8, further improved the model's performance and added new features. Okay, so Ultralytics really, they're not responsible for the previous YOLO versions, but the first one they really released was YOLOv8. YOLO has been widely used in a variety of applications, including autonomous vehicles, security surveillance, and medical imaging. They're all just detection, segmentation tasks. It also been used to win several competitions, such as the Coco Object Detection Challenge and the Dota Object Detection Challenge. History, you can refer to YOLO paper, and then and yeah, this guy was pretty cool, right? Like, he not only was he just technically a badass, and he like wrote this entire model in his own framework, written entirely in C, but also quite humorous. He actually named the YOLOv8 paper YOLO 9000, better, faster, stronger. Okay, YOLOv8 is the latest version of the YOLO object detection and image segmentation model developed by Ultralytics. One key feature of YOLOv8 is the extensibility. It is designed as a framework that supports all previous versions of YOLO, making it easy to switch between different versions and compare their performance. YOLOv8 includes a number of other innovations. A new backbone network, so I bet you they're using a transformer, the vision transformer from Facebook, VIT. New anchor-free detection head and a new loss function. So that kind of sounds highly efficient and can run on CPUs and GPUs. Okay. YOLOv8 is flexible and okay, so that's a nice little summary of YOLOv8. So we went ahead, we already did this. Pip install, git clone. YOLO command CLI lets you have that. Type dash. Yeah, it's there. Okay. CLI powered by Hydra. Override anything config. CLI guide. So I don't really want to necessarily use the CLI. I hate having to type things. I prefer just Python APIs because then you can have like an actual history. You can commit it to your GitHub. You can go back and see what actually you typed versus CLIs. You have to basically make either bash scripts or. So why don't we, let's put this in the Etherum repo. So a new watcher to this channel. So GitHub called Betterer, and this is just kind of like a scratch paper repo, but I'll go ahead and I'll put stuff in here. So if you guys want to eventually get the code for this, feel free to find it. So go into Betterer. Let's pull. So we're have any changes that we might have done on different computers. And here's a folder that makes sense. Python, Kaggle, data, make a new folder. Make a folder. And up code. That gets started. File from that, and we're going to save this as YOLOv8.py. YOLOv8. Control B to close out that side panel. First thing we notice here is that in the imports, right, this is underlined. VS Code is complaining that it doesn't know what this Ultralytics dependency is. So what we realize is if we actually go down here into the bottom corner of VS Code, you see that it's not using the right Python environment. So let's go ahead and click that, and let's make it use the YOLOv8 environment that we created. So if you do that, you see that stops complaining about this import here, and it says, okay, I actually know. All right, so if we look at their examples here, they have you load a model. You can either YOLOv8 and YAML, so if you want to build a model from scratch, or if you want to load a pre-trained model. I think let's just do the pre-trained model, this one. Why don't we actually okay, so now we're breakpointing through this file with VS Code. We can here quickly we class variable. On this, we need now we should have nope. Problem is that if we run, then it back. Using the model. Results equals model.train. Results. This is how you would train the model. This is how you get results or evaluate the model performance on the validation set, and then here's how you would predict on image. So why don't we go ahead and copy that. And let's find some image. Go to the Ultralytics YOLOv8 master. Actually, the 5. Okay, so there's have Zidane and us. Image. So obviously they picked those because they're useful. So let's find humans doing how about this one? Let's not try to find stuff on the, but you know, we go in. Go into our channel. And let's just copy, paste. Ooh, no, even better. Let's use, right? Let's give it some of these pictures. Your AI generated. Shift print screen. Snapshot. Select area grab. Got. AI generated ski. I don't know exactly if that's what library folder. Model is like VS codes like Abby. So go into our normal YOLOv8. Outputs. Let's click on like behavior. Predict. outputs equal. Go ahead and print that, see what happens. Generator object base predictor. Accepts all formats. 0 for webcam. Model.predict. Go. Okay, so here, this is the format of the outputs. It's going to be a dictionary with detections and segments, probabilities. So why don't we actually happens? Still nothing. Okay, so we want to save this. If we output this here. Oh, it came there very briefly. It appeared. Error segment. Okay, I guess there's no. That. The error prob. Okay, so probability is part of it. What is that window that's popping up? Let's see the title real quick. Copy. POG is an image. Actually look. So YOLOv8 summary was 168 layers model, around 300,000 parameters. That's the section array of XY, score, and then CLS. So this is the class. This is the position of the bounding box, size of the bounding box, and that's score. So actually, we go here. This is the position of the bounding box, so 99, 199. This is the size of the bounding box, 402 by 643. And then these are the scores. So it's not super confident, right? This is not like a 0.99 prediction. This is like a relatively low confidence prediction here. And then this is the class, right? And classes are actually correct, right? 3 people, 1 motorcycle. I would say that's exactly what's in the AI generated image. So let's go ahead and see if we can find in the station how to actually image out. Predict on an image, export model to ONNX format. Okay, here you have the different size models. For model name in YOLOv8 have YOLOv8 S. So N is nano, probably S is small, then M is medium, then L is large, and then V8 X is X large. Let's try the medium. M, L, X. That's GitHub Copilot. GitHub Copilot is not trained on this. Classification. This is what I want. I want a picture. Train. Predict. So how do I take these results, plot them on an image? What if I use the CLI? CLI command predict. That. Okay, it's running. Results saved to runs detect predict. CD runs detect predict. AI schema. All right, look at that. So this is the predictions on our little image here. Remember, this is an AI generated image. People aren't real. This schemobile isn't either. You have one bounding box for this person. You have another bounding box for this person. So what this is saying to me is there's you have been a little bit more non-maximum suppression. NMS suppression is basically a way of total amount of predicted bounding boxes, depending on whether or not they're overlapping. And these scores are also relatively low. Actually, change the task segment happens here. Open up. Go back. All right, we're here. Let's run this. Runtime mat1 and mat2 shapes cannot be multiplied. It's called segment. They actually have a way to segment mode val segment predict. Okay, so YOLOv8n -seg. Run it. Downloading the application model. Megabytes. It also detected the motorcycle, and let's POG runs segment. Damn, you know, that's pretty good. All right, we're zooming. That's pretty clean. It missed kind of this part of the snowmobile, the like little ski parts, but it actually predicted motorcycle anyways. The people, it's a little bit confused about what legs and arms belong to what person, but I think honestly I'm a little confused. So let's see, we give it another AI generated. Let's give it this one. Otters. Got. Select area of the screen. Grab, take. Got. We're going to give it this. Otters. And we're going to put it in the folder. We're going to call it Otters. AI generated otters. Save. Back into back to otter. that. Action. All right. Now, predict 2 AI generate otters. Low confidence prediction of bird, and then a higher confidence prediction of bear. So AI generated otters are not recognizable by YOLOv8. Let's generate runs segment, then predict 3 AI generate. Okay, so the segmentation model segmentations are pretty clean. It doesn't get the selection of the otter, but it is guessing bear and dog, and they are relatively low confidence. So okay. That was the small one. So this is YOLOv8n. So let's see what happens if we do this with. Let's try the YOLOv8x, which is the big model. Okay, so the big model, for context, the small model was 6.74 megabytes. The big model is 131 megabytes. Okay, so the bigger model thinks they're both bears. The confidence on these predictions is a little bit higher. So this number here is what I keep calling the confidence, and that's basically this detection head. It has a bunch of classes or categories that it can predict for each of these bounding boxes. And it's basically like a classification task where for each class that it has available, it's going to predict a probability. You can think of it as a probability between 0 and 1 of how likely is this thing to be this class. And this is the top one. So this is probably, the model probably predicted this as 0.001 motorcycle and 0.62 bear. And so the highest one, the highest confidence class that it had was bear, and that's the one that's showing right now. But the highest confidence out of all the ones that it had was just 0.62, right? So that's another thing to note there, is that these confidences are not super high. Let's see what the segmentation. Now this is runs segment 4. Okay, it's the same. We have bear for both of these. 0.63, 0.64. Okay. All right, so export a YOLOv8 model to different formats. So these are different deep learning frameworks, right? So everybody knows PyTorch, everybody knows TensorFlow. TensorFlow Lite is a small format generally used for embedded devices. TensorFlow Edge TPU is specifically for a Edge TPU, which I think is kind of looks like a Raspberry Pi. Yeah, this is what it is. This is what it is. So this is basically like a little Raspberry Pi. This is just a big heat sink, right? And then on there is a small little tiny TPU. So these YOLO models, kind of the bread and butter for these YOLO models is like edge devices. Like what really set apart the original YOLO models was the speed. So they became popular for edge devices and kind of IoT computer vision applications. So it makes sense to me that they have a variety of export formats for the small model, right? ONNX, this is actually Chainer. Open Neural Network Exchange. This one, yeah, so this is the one that a lot of Chinese companies use. So you hear Alibaba, Baidu, variety of Chinese tech companies here. So they're still going strong here. Recently released a V1.3. What else do we have here? RT, TorchScript. TorchScript is actually kind of like the legacy version of PyTorch. I don't think anybody even... Okay, actually, so TorchScript doesn't refer to the original framework that eventually became PyTorch. It's a way to create serializable models. So it's basically like Torch. So GIT here is just in time, which is basically compiling when you run things. So languages like obviously like C++, that you compile them and then you run that compiled source code. But Python doesn't do that. Python, you just run it and it just basically runs it as it reads it line by line. But things like JAX and it seems like TorchScript are intelligent about that, and they'll compile it as it runs, and then if you run the same thing over again, it'll run the compiled version. All right, what is paddle? Paddle. Paddle is the first independent R&D deep learning platform in China and has officially been open source to professional community industrial platform with advanced technologies that cover framework. Okay, so this is basically just the Chinese did deep, very active. 20K stars is nothing to scoff at. December 13th, to these 683 contributors. Definitely busy framework. Okay. You can export to a variety of different models. Maybe click on here to the different models. Let's actually look at the difference between the Nano, which is the one we have here, and then the X, which Nano is the small one, and X is the big one. Get big. Okay. So this is the backbone, which is basically the first part of the model. So the image first gets fed through this backbone, and then it'll get fed to each separate heads. So you can actually see here if we compare. So this is the one. You can see the difference in the backbones. But first of all, if you look at here, so this is the number of classes. So remember how we said it had human, bear, motorcycle. So there's basically 80 classes total, right? So actually the chance that there was an otter class is actually pretty low. Depth multiple, scales, module repeats, scales, channels. So basically this makes things smaller here, and this kind of zooms in, kind of what I'm getting at. So here in the backbone, have first convolution is 64 repeats. Oh, okay, no, I think this is the from, this is the repeat, this is the module, and this is the... You can actually see the first couple layers are actually all the same here. In fact, pretty much most of this is the same. It's really only the last 3 layers that are different, right? Everything up until here is the same, and then in the small model here, YOLOv8n goes 10, 512, 512, 512. Kind of weird. Why is this one smaller? Very confused. Does n mean nano, or does n just... thought n would be the smaller model here. Actually, we can probably go to... Let's comment out everything. Let's print out the model info for the n and the x. Okay, so small model here, YOLOv8n, it is smaller, it has less layers. It also has about half the amount of parameters, so 315,000 parameters, and roughly 8.9 gigaflops from inference. YOLOv8x is bigger, it has deeper, so it's deeper, it has more layers. It has significantly more parameters, right? It has 68 million parameters, 8,229,048 parameters. Oh, actually, I'm wrong here. So it's not 315,000. It's 3,157,100. So this is a 3 million parameter model. This is a 6 million parameter model, so it's roughly twice as big. And 258 gigaflops. So you can actually see that because the amount of parameters, right, the way neural networks work, every neurons tend to be connected to a bunch of other neurons. So like the more neurons you have, the more of these connections there are, and very quickly kind of the total amount of inference time will explode. So that's why this n model here only takes 8.9 gigaflops, but this large model takes 208 gigaflops. Okay. Verified that N is the small one and M is X is the big one. So it is a little bit weird that the 8 model has a smaller width here. I think that's because even though this number here is smaller, even though 512, the width of this, I think this might be the number of channels in this convolution operation. Even though this is bigger than this, I think you're multiplying it by this, right? So 1.25 times 512 bigger than 0.25 times activate 8. YOLOv8 N size 1024 5. Then the 8x size 512 times print YOLOv8 size should be greater than the YOLO size. Are correct. Yep. Okay. So we're not insane. The big model is bigger. It just was a little bit. They're using these numbers up here to multiply what's. And then module repeats. I think this is probably one full. Right. You see here the module. So it probably repeats this a bunch of times. Right, because we know from our there's 365 layers, so this is way less than 365. So it's probably this repeated, stacked on top of each other. So that's another way that this looks bigger. Okay, now let's actually compare the heads, and these might actually be more similar than different. These might actually be exactly the same, if I had to guess. Largely the same here. This is basically the same. -1, 4, 1, concat 6. About this one here, also the same. And this one is slightly different. This one has 1024. Here. This one has 512. Okay, and then last part here. NC. So NC probably stands for number of classes, which is NC80. So that's the actual final output dimension. Okay, so that's models there. 8 CLS, what is this? Oh, this is the classification model. Yeah, so for example, the classification model, it has the same backbone, but it's going to have a much higher number of classes. And then see here, the NC is going to be 1,000. So actually, I'm curious. One thing we can try here is so when we were predicting our little doggos, or our little otters, right? It predicted bear. But this is the detection model, and the detection model only had 80 classes. I wonder if we go to the classification model, which has 1,000 different classes, it'll have an otter class, or maybe a class that's a little bit closer to otter than bear. Try that. Here. Asks Asian. Ask, classify, and then add the CLS. That script here. Otters. Add the now try the classify task mode prediction. I think, and let's see if there's a difference between a small one. So N YOLOv8x. Copy that. Paste it. Downloading the classification model. It's a little more than the segmentation model because there's less heads. Now let's run. So that was the small model. This is the big model. So you see the difference here. 5.28 megabytes for the small classification model and 1,100, or not 1,100, sorry, 110 megabytes for the big model. So it runs classify predict 2, or predict, and also dog runs classify predict 2. Not very useful. I don't know what the category is. N03207. What the hell does that mean? What? Is there like a reference for what these classes are? Models, CLS, Ultralytics, YOLO, Bigs. Let's search this. YOLO data augment for labels and mosaic labels and CLS, single CLS, CLS loss. Names.index. What if we let's write down what is the actual thing it said. It as N03079. Search that in this. Nope. Search that on Google. So in this weird website, N0320941 means dishwasher, dishwashing machine. Yeah, that's probably someone who wrote that. No, I mean, that is correct. That is dishwasher. That is otters. Is that the right thing? Your N03. 207-941. What about the big one? The big model also predict that? Okay, no, the big model was a different class. The big model, all model predicted that, which means big model predicts n 0 1 1 1 500. Holy shit. I mean, you guys see this right here? GitHub Copilot is auto-completing this random tag here to Great Pyrenees. Okay, which is a type of dog. Yeah. Weird. Okay, so that's a higher prediction. So that's cool. So the classification model does have significant difference between the small model and the big model. But I'm just more impressed that GitHub Copilot knew what the code for this was. Ultralytics Hub. What is Ultralytics? This is where they plug their startup, and let's see what their startup is trying to do. New no-code online tool. Popular. Ultralytics Hub users can deploy models without any coding or tech. Upload their data, select their model configurations. Deployed and used for real-time and image generation. Basically, like a no-code model train. Have an app that allows you to just use different models if you want. Validator predictor. Okay, so the predictor object path to video file, video writer for save output, directory. Can we just do this? Savedir is not a valid key. Save. save. Not save. So if I give one piece of feedback, I feel like their Python API should have an example where it just outputs it and prints it. But it seems like this CLI is really that. Path to the wait files. Done. Answer. Oh, here we go. Visualize. So wait up. Put that in there. Is that finally what we wanted? Move the runs directory. Let's oh. Forward. Verb equals true. Yeah, okay, so then it just kind of prints the so this is the actual every single layer, right? Actually see the amount of parameters for each individual layer here. So you have your convolutional layer, you have your batch norm, right? Batch normalization there's a weight and a bias to it. Then you have another conv layer here. Have the batch normalization for that, right? And you can see here how this layer, for example, has a batch size of 32, which means that the batch normalization also has 32 parameters. This first layer here, batch size of 16, that the batch normal size of 16. And you can also see how, for example, the first batch normalization here, right? Look at this standard deviation, 1.6, 4.16, 1.2, 1.5. So like as you go deeper into the model, size of the variance of the batch normalization So another interesting thing to note here, right, where actually the number of parameters for the initial layers smaller than the deeper you go into the model, the more parameters you need, because the channels dimension keeps growing. Right, like look at these convolutions. So these are 1x1 convolutions, but they have 1,280 channels, so quite huge. And then, of course, this is the segmentation or detection model, so it has 80 total very end. This is the final head that actually classifies your thing into one of 80 categories. Cool. So go ahead. We'll see this sub editor here. I want to save these .pt files, so just better than that. Let's go into our better repo here. Let's open up the git ignore. m.git was there. Data saved models. We don't want add an extra star.pt. So add.git ignore. What that's going to do is we're basically tell git to ignore these files. So let's go ahead and refresh here. See, git is like, okay, I understand now. You don't want me to add these git ignore files. I log as well. And let's add this. And then we'll say state exploration. Git ignore and the YOLOv8, and we'll cool. A nice cute little stream there. Thanks for listening, and thanks for watching, I guess. But yeah, that was a little quick review of the new YOLOv8, which is coming out of a startup called Ultralytics, which is also very fresh. And yeah, it seems fine. We're giving it some AI generated images, and it kind of choked a little bit, but it was fast, and the overall experience was pretty smooth. No dependency issues, no random bugs. We were able to run everything quite cleanly and quite easily. You can actually look at the chart here. This is the different models. So we were playing with the N model, which is the small one, right? It's the fastest. So this x-axis here is the latency, which basically just means the speed of the model, right? The small model is going to be faster. And then this y-axis, COCO, MAP, 50 to 95. This is basically mean average precision, which is, you can roughly think of it as how good this model is. So you can see how the X model that we were playing with is better than the L model, which is better than the M, which is better than the S, which is better than the N. But you're basically trading off speed and performance here. So if you want something that runs on a tiny little embedded device and it runs as fast as possible, you're going to be using the N model. If you want something that runs once a minute on a huge computer, you're going to want this X model. Yeah, that's YOLOv8, and thanks for watching, and we'll see you guys